Let's talk about maximizing network performance for your HPC workloads when you're using PCS. In this video, we're going to dive into the world of Elastic Fabric Adapter, or EFA, and also into instances that have multiple network interface cards, or NICs for short.
PCS is growing quickly, so we want you to know that if you see a message on your screen in YouTube here, there's a good chance that the video that you're watching right now has been replaced with a newer version. It might be a small change or a really big one, but either way, your life will be more pleasant if you watch the one that describes how PCS works today, not how it was in the past when we launched the service.
For high-performance computing, network throughput is critical, and that's where multi-NIC instances totally shine. So these powerhouses can deliver bandwidth capabilities well over 100 gigabits, and they have impressive packet handling rates, and that's because they've got more than one pipe to handle network traffic. So when you pair that up with EFA, which dramatically reduces latency, you've got a combination that can really accelerate your HPC workloads. Getting EFA going with PCS takes just a few steps. So first, you need to select an EC2 instance that supports EFA. And you need to learn how many network cards that instance has. Now that's the easy part. The next thing you need to do is set up some resources outside of PCS. Number one, you need an EFA Security Group, and that lets all the EFAs talk to one another. Physical proximity is king in HPC networking, even in the cloud. And after all, the speed of light's not just a good idea, it happens to be the law. So to help with that, you need a cluster placement group. That helps EC2 know that you want all your instances to launch close together. You need a launch template that shows PCS how to configure EFAs for its instances. And that launch template relies on the security group and the placement group. So there's an order of operations in how you create things. Fourth and finally, the AMI you're using needs to have the EFA software installed on it. Now, if you're using the PCS sample AMI, it's going to be there by default. But for other AMIs, you're going to need to install it. Now, just a quick aside here. If you haven't checked out our video on how AMIs and launch templates, instance profiles, and security groups all work together, now might be a good time, because it provides some good context for the steps that we're going to take to enable EFA. So finally, you've picked your instance type, you've set up all the external resources, you can configure a PCS compute node group to use them. Now, this might seem complicated, and it kind of is the first time you do it, but if you stick with me, you're going to be up and running in no time. What we're going to do now is walk through each step that I outlined before. We'll use the AWS Management Console, the AWS CLI, and of course, some helpful CloudFormation templates to get everything set up. And at that point, you will have an EFA-enabled PCS environment that's ready to handle your compute-intensive workloads. You can use that as it is, or you can adapt it to your own needs. Let's get to it. Let's figure out what instance types support EFA. To do that, you can go to the EC2 user guide, or you can use the AWS CLI. So the user guide, we can see some bullet-pointed lists. Basically, most of the high-performance type instances that you would use for HPC are here. You can also use the CLI. Let's pop up in a terminal window. Note that this is region specific. In that command, I specified US East 1, but I'm actually going to be working in US East 2, so the list of EFA instances will vary based on what region you're in. Most EC2 instances have a single network card, but many of the ones that we're interested in have multiples. And you need to know how many are in a given instance because each NIC needs its own EFA adapter in order to get maximum performance. So you can find this out in the user guide. Again, here in the Amazon EC2 user guide, there's a table of multi-NIC instances. As far as I know, there's not a CLI lookup for this information. So go to the user guide. HPC 6A instances aren't on here, and that means that they have a single network card. Most EC2 instances do. But we're interested today in HPC 7A instances. And we'll note that HPC 7A instances in all various sizes have 2 network cards. So it's a little bit more complicated to go from HPC 6A to 7A than just changing instance types, because you also need to update your PCS launch template to accommodate the additional EFA. It's a little bit more complexity, but you get to go from 100 gig networking to 300 gig networking, so it's probably worth the trade-off. Okay, so speaking of HPC 7A, let's forge ahead, set up an EFA-enabled PCS node group that uses this instance type. So within your compute node group, all your EFAs have to be able to talk to one another, and you make that happen with a security group. Now, I recommend you have a dedicated EFA security group for each compute node group. I'm going to set one up here with a CloudFormation template, but it's easy enough to do this with the CLI or the console. There's just 2 rules. It's a self-referencing security group, and it has to allow incoming and outgoing traffic on all ports, all protocols between all members of the group. EFA Security Group. So let's give it a stack name. EFA Demo Security Group. You can name your security group, and you select the VPC where you're going to be using PCS, in this case HPC networking. We finish this off, and in literally just a couple of minutes this will come up and we'll show you the security group that gets created. Okay, so it's done. Let's go look at the resources. Here's our EFA Security Group. There it is. Let's go look at the rules. Inbound, rules, all traffic, all protocols, and the source is the same security group as the defining security group. This is why it's a self-referencing security group. The same rule for outbound. Here's our security group, all traffic, all protocols, and the destination, that means traffic can go to any members of this security group. That's all you have to do. Okay, so next, we need a cluster placement group. You can create one of these in the console. You can use the CLI, or you can use CloudFormation. 3 guesses what I'm going to do, but I'll show you where this is in the EC2 console in case you want to do it yourself this way. So you go to EC2, go to networking and security, and go to placement groups. You can see I've already got one in here from another cluster. EFA Demo Placement Group. In this case, you got to pick your placement strategy. There are actually different types of placement groups. The one that we care about is cluster. A cluster placement group is a hint that tells EC2 to launch the instances close together. Okay, so we'll kick that off. There's nothing really to look at. Let's go ahead and I'll show you the CloudFormation stack too. Again, this is available in the HPC recipe associated with this video under the assets directory. My placement group, or some stupid name like that. And there we go. We don't need to hang around for this because it's not a particularly exciting outcome. So now it's time to go and create the launch template. So the launch template needs to accomplish 2 things. It needs to tell PCS about the cluster placement group, and it needs to define the right number of network interfaces in the right subnet with the EFA security group attached. That's what you're trying to accomplish. So you can set up launch templates in the EC2 console. I find that a little complicated, and I have to remember what to click each time. I really prefer to use infrastructure as code for launch templates, so that's what we're going to do. So let's create a stack. Here is PCS-011 This is again in that HPC recipe. Okay, so now let's look at the inputs. Okay, so under networking, we got to choose the number of network cards. Remember, HPC 7A instances have 2 network cards, so we've got to pick 2. This is kind of a magical CloudFormation template because it can create the right number of network interfaces up to 4 network cards. And I'll actually show you how that works in just a second. Okay, so now we pick our VPC. That has to be the VPC where the cluster is, where we're working with PCS. And our subnet. Now, this is important. This is the subnet in the cluster VPC where we're going to launch HPC 7A instances. Since this is an HPC instance type, it needs to be, the subnet needs to be in US East 2B because we're in US East 2. In my account, that is private subnet A. You note that we have US East 2B as the suffix on there. Okay, so we can specify a placement group name. So we could use the one that we just created. If we don't put in a name for the placement group, this CloudFormation template will actually create one for us. So I'm just going to leave it empty. Now we need to pick our cluster security group. And there's another security group as well. So our cluster security group is cluster, and we're going to add it to the getting started cluster. Since I've named my security groups after the names of the clusters, this is easy to remember. And since a lot of HPC workflows rely on SSH in or out of the node, even within the cluster, we also add an SSH security group that allows SSH ingress into the nodes. You don't have to do this, but if your workflows rely on SSH, then you will need to do this. Since we're providing that, we need to provide an SSH key pair name, and now we need to name the launch template. What I like to do is I like to incorporate the node group name that I'm going to create into my launch template. Okay, just a reminder though, this has to be unique in your account and within the selected region. So let's do HPC7A demo EFA. All right, we'll kick this off. While this is cooking, let's actually go and look at the source code for this CloudFormation template, because this one's pretty interesting. Okay, so here we are. We have our parameters. We have our placement group name. Notice that the default is empty. This is what allows us to provide an empty value when we're launching the template. And the number of network cards has a constrained set of values, 1, 2, or 4. That's how you implement a drop-down list in CloudFormation. Let's scroll down to our conditions. Okay, so here's one condition, create placement group. This gets set to true if the placement group name is empty. And this is we use this conditional elsewhere anytime there's a choice between the user provided placement group name and the placement group that gets theoretically created by the template. We use this conditional to implement that behavior. Then we have a set of chain conditions regarding the number of cards in the instance. So these are all contingent on the value of card count. You can see that someday in the future, I plan to support 8, 16, and 32 cards, but the current instantiation of this, we just have the conditionals in place. This is a little bit weird. This is kind of a vagary of CloudFormation. Basically, if you want complex conditional logic, you may want to consider using CDK or some other actual programming language to write your infrastructure as code. CloudFormation is supposed to be declarative, and they kind of draw the line at yes or no binary conditional behaviors rather than greater than or less than. Okay, so let's go down to our resources. So we're going to skip over creating the placement groups. We actually do that with a Lambda to work around a constraint in the way that placement groups can get created in CloudFormation. We'll skip over the security groups, and let's go down to the launch template. This is really the meat and potatoes of this whole exercise. Okay, so here's our launch template. This is the physical asset that's getting created in EC2. The data for the launch template is in launch template data, and this maps to the values that you can find in the user guide for launch templates. We tag all the instances that are created with this launch template. In this case, I tag them with HPC recipes true. We set IMDS, instance metadata server, to version 2. That's the setting here for metadata options. Now we get to the EFA specific stuff. Here we set our placement group. So the placement group name is either what was generated by the template. That's if the conditional for create placement group is true, then we use the generated placement group name. Otherwise, we use the placement group name that's provided as a parameter. So now let's go ahead and look at network interfaces. This is really the beating heart of setting up EFA in a launch template. So every network device has a device index. Basically, the network card whose device index is 0 is the primary network interface. We set an interface type of EFA. Otherwise, if you're just setting up regular network interfaces, this isn't mandatory. You can leave this out, but we're explicitly saying we want this interface type to be an EFA. We provide a network card index. The primary network interface has to have a network card index also of 0. So the device index is 0, the network card index is 0. Then we provide our subnet. So for the subnet, we're telling EC2 to create an EFA in this subnet, then attach it to the instance that's also going to get launched in this subnet. 99% of the time, this means that these two subnets should be identical. In this case, we want that private subnet in US East 2B because that's where the HPC-7A instances are. And you'll remember that that's what we set when we created the template. And finally, within the network interface, we set groups. So in other launch templates, you might see security group IDs. Those are their own top-level setting in a launch template. So when you are working with a launch template that has defined network interfaces, you can't use security group IDs. Instead, and especially if you're setting up EFA, you have to define the security groups individually for each network interface. They can all be the same, but they have to be defined individually. So what we're doing here is we are on our primary network interface, we're adding our EFA security group, the cluster security group, allowing communications with the controller and the various Slurm daemons, Slurm control daemons, srun, etc., and that SSH security group ID. And that's basically it for our primary network interface. However, since we specified 2 cards, we will also be providing a second network interface when we build this launch template. So here, this is implemented with this conditional, if card count is 2. Here, our device index is 1. And all the other device indexes, if we built additional network interfaces, all have a device index of 1. All this means is these are not the primary network interface. They all have an interface type of EFA. Their network card indexes are numbered sequentially. So my second card is 1, my third card is 2, my fourth card is 3. We specify subnet, we specify groups. You'll note that I only specify the EFA security group for the additional network interfaces. Communications with the cluster, inbound communications over SSH all take place over the primary network interface. That's why we have a primary network interface. So let's go back to the CloudFormation stack. And here it is. Here's our resources. Here you can see we created an EFA security group. We created a launch template, we created placement group, etc., etc. So this is ready to go. So now we can go ahead and we can go create an EFA ready node group in PCS. Let's pop over to the PCS console. We're going to add this to the getting started cluster. We'll go to compute node groups and we'll create a compute node group, PC-7A. Remember, I like to use the launch template that's named after my eventual compute node group. This is just a bookkeeping thing. I have the memory of a goldfish. So now it's real easy to find the launch template that we created. As usual, we need an instance profile, and we need the subnet where the instances are going to get launched. In this case, we need that one that's going to be in US East 2B. I can't stress enough, this has to be the same subnet as your EFAs in the launch template. Okay, instance types, HPC-7A. We have a big fella here, 96x large. We'll set our scaling configuration between 0 and 4 instances. And now we need to provide an AMI. So I'm going to be lazy and use the sample AMI where we know the EFA software is installed. And bazinga. It is creating. So we'll wait a couple of minutes for this to create, and then we can go and we can add it to our queue. And once this node group is added to either its own queue or another queue, I'd probably recommend putting it in its own queue. You'll be able to use it to submit jobs. All right, so let's wait a minute here. Okay, so we are in the compute node groups panel in our cluster. We can see the HPC-7A demo is ready. Let's go add a queue, EFA, and we'll throw the HPC-7A demo node group there. And in a minute or so, if you were to log into the cluster, I'm not going to do this, but if you were to log into the cluster, you will see that there's a new queue that shows up that has instances named HPC-7A-demo-1 through 4. And those will be your virtual instances that can get spun up or spun down depending on the load on your cluster. So there we have it. We've added a compute node group to our cluster that launches HPC-7A instances. They can communicate over EFA. This involved a few different steps, but we made it easy with a CloudFormation template that you can use to create your own node groups and your own cluster. So in terms of the next steps, you might want to bring up some EFA-enabled nodes and run tests and benchmarks on them. There's a lot of information about that online. It's not really PCS specific. But once you've done all that, then you should be ready to start using your EFA-powered node group for real workloads. Congratulations on your hard work in this tutorial, and welcome to the Life in the Fast Lane with EFA and PCS.